So let's take a look at them together right quick. If a weather system is with strong winds approaches Lake Michigan from the west, how might the speed change as it crosses the lake? Actually, the west has nothing to do with it. I'm thinking frictional forces. Yeah. So assuming it has the same pressure gradient force, what do you think when it hits the smoother surface?
Slow down that much, but isn't it just hitting like a smooth watery surface?
Mm-hmm.
So I don't think it'd like change that much if anything, be my guess.
Well, let's say it's got the same, the pressure gradient force that was there when it was on the land is the same pressure, same force as when it's smooth.
Accelerate maybe?
I think
Accelerate?
it'd go faster. So something like that, that's what I'm thinking. The next one has a figure to go with it, so 4, and 4 has a little asterisk. So number 3, you have to use complete sentences technically to get full credit. And number 4, you could just jot down what the answer is. So, so this map, blah, 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 A says which of these cells, so there's 3 cells, 1, 2, and 3, which of them are central high pressures, anticyclones? Which ones are lows? So, like 1, what do you think 1 is?
That looks like a sort of high, oh,
How many people think it's a low? How many people think it's a high? I think it's a central
It's
low.
low, isn't it?
Mhm.
Yeah.
Why is it low?
I can't remember the word for it. It's either, is it the ridges? Does that have to do with it, or is?
Oh, it could be the troughs and ridges.
Yeah,
I think it has to
troughs.
do with the 996 and 1004, 1000,
Oh, okay.
996, 1000, 1004, 1008. So if those are the isobars and they're getting bigger, then there must be a hole in the middle. Does that make sense?
yeah.
So what about 2? What would you say? So I'm going to put an L for 1.
Might be the opposite then.
Yeah, I think the opposite too. So we have 2024, 2020, 2016. So I think a high pressure. And then what about 3?
Lower again?
I'm thinking low. I mean, I don't mean to do your homework for you. I'm thinking low. So we talked about kind of how close they are, how far apart they are. If they're close, we call that a steep gradient, in this case pressure gradient. So which one has the steepest pressure gradient? It's close. It's kind of hard to tell. Well, which one has the floppiest gradient, the lowest gradient? Which one's the farthest apart?
2 would be the farthest apart.
I think 2 would be the farthest apart, I agree. To me, 3 and 1 look kind of similar, but maybe,
I think 3 with the first
Yeah.
3, they look far closer than 1.
yeah, I'm kind of liking 3 also. I think this looks, it's close though. Determine whether pressure system 3 should be considered strong or weak. Oh, and I didn't look this up, so this shouldn't hopefully be too bad. So you'll just look up that figure. Good. The next one looks like this. Given this information, what would you think with regard to cloudiness and precipitation for these days? Now here's your hint for this one. Early on in this chapter, last week we talked about, what if I put, I'm talking pressure tendency, what if I put an up arrow? What does that mean with pressure tendency? What's the pressure doing? Rising, yep. That's rising pressure, and that generally brings what we call, well, not, we don't call them, but basically that generally brings clear skies. Okay. Falling pressure generally brings cloudy skies. Similarly, and remember, this might ring a bell. Last week we looked at different ways to measure pressure, and the gauge that you might have on your wall is like an aneroid barometer, and it has fair skies. See which way? Fair skies over here, maybe fair skies over here for high pressure, and cloudiness over here for low pressure. Okay, so along those lines, as you evaluate this, let's see, high pressures. High pressures, rising pressure, clear skies, low pressures, falling pressures, cloudy skies. So I think just kind of use that. We won't go through each one of those, but that'd be my hint. And the next two are here. So this looks like a windrose, right? Which direction is the wind coming from predominantly?
Northeast.
Yep, from the northeast, exactly. And number 8 goes on to say that you're designing an airport and you're supposed to have planes take off into the wind. Okay, and so if the wind is coming from the northeast, then you want to take off from,
Southwest.
I think so. And then the last one, so you're supposed to use complete sentences for both of these. The last one says, the meteorologist says that the barometric pressure is 28.8 inches and rising. And then you have a friend ask you, basically says, I thought air pressure had something to do with the weight of the air. How come, what's the inches? And my hint to you is to revisit the idea of a mercury barometer. Like mercury's a liquid at normal earth temperatures and pressures. Okay, a mercury barometer, that's where actually they get the inches from. So remember, it's like inches of mercury that goes up the column. And then he says, do you think the weather's going to improve? Oh, yeah. So then I go back to what the first question or an earlier question was. He says it's rising. So what would you say? I think it's going to, yeah. The barometric pressure is rising, so that's tendency. So, yeah. So let's go ahead and take a look at a few slides in Chapter 7, and then we'll call it a night. So now that we talked about how wind is created and how wind is deflected and kind of the anticyclones, cyclones, that sort of thing, we're going to continue on talking about, what are we going to be talking about? Oh, yeah. We're going to talk about more about wind. And wind actually comes in 3 flavors or 3 scales. The largest scale is called macro scale, sometimes called planetary scale. Things that are big, they last longer, okay? And so some examples of macro scale winds would be your hurricanes. The generic name for hurricane is a tropical cyclone, so we'll be talking more about that later, but if you ever see the word tropical cyclone, that's our hurricanes. Those H's and L's, the anticyclones and cyclones, those are macro scale winds. Then we get to the middle scale winds, and actually these are sometimes called local winds, so if on your notes you want to put the word local winds, it's the same thing. They're medium scale, so they don't last as long. Instead of like days and maybe even weeks, they last for hours. Examples of those would be thunderstorms, tornadoes, sea breezes. And then we have our short scale winds, our micro scale winds, which those are much more random. Your textbook, I think, does a good job talking about dust devils. And a dust devil is an example of a micro scale wind. They don't last very long at all. So here's a good figure from your textbook, I think, kind of from left to right. You see the small scale, medium scale are called, so we have microscale, meso or medium scale local winds, and then over here we have our macro scale, our planetary scale winds. So you can kind of see how long they last and how big they are, and examples of them. But they're all caused by the same thing, wind moving from a high to a low pressure. So here tonight, before we go home, we're going to kind of take a look at each one of these. With one more in the list, we're going to take a look at Santa Ana winds. So if somebody says local winds, that's local winds and mesoscale mean the same thing. And in most of these cases, what is creating the difference, the high and low pressure, actually is a temperature. So I kind of want you to remember, in general, warm air is a low pressure, and cold air is a high pressure. All right. So this one we already covered before. We're going to take one more look at it. This local wind, sea and land breeze. And this was the one where I said in that previous chapter, it's kind of like if you've been to Chicago and you have off of Lake Michigan in the afternoon, kind of an incoming breeze. Okay. What's happening is that actually the land is heated up more quickly. My land is heated up more quickly and creates a low pressure in in Chicago, and Lake Michigan is a high pressure, so you have a lake breeze. There in Chicago, you should experience in the evening then an outgoing breeze, a breeze from the city back out to Lake Michigan, because in that case, the city cools down more quickly than Lake Michigan, and it creates a high pressure in the city, and it goes out to the lake. So here's those pictures again. So with all of these breezes and winds or whatever, you know the direction they're coming from by the word. So a lake or sea breeze actually is coming from the lake or the sea, and a land breeze is going out to the lake or the sea. So ebb and flow, ebb and flow. So there are these pair of winds, a valley and a mountain breeze, and they alternate as the sun rises and sun sets. And they're caused by differences in temperatures because the air is thinner up at upper elevations. It heats up and cools down more quickly, just like the land heated up and cooled down more quickly with regard to the ocean. So it creates basically, during the early part of the day, we have nice, warm, toasty at a low pressure at upper elevations, so we have a valley breeze, okay? And then as the sun sets, the thin air cools down more quickly, and since it's cold, now it's a high pressure that goes down the slope of the mountain, okay? So we call that a mountain breeze going towards the valley. So this is our valley breeze, again created as the thinner air at upper elevations heated more quickly, and so created a low pressure up there. And this is our mountain breeze going from the top of the mountain down to the valley. And this slide kind of says this sort of movement of cold sinking air like this actually can create these pockets of cold air down here, which, especially here with the old Appalachian Mountains, you'll hear kind of these ice storms where they end up with just nasty driving conditions here because they've got these thin kind of pockets of cold air, temperature inversions. All right, so another winds. Now these winds are the same, Chinook and Foehn winds. And they are in the downwind side of a mountain. We have a couple of winds associated with mountains. These are associated with the Rockies. They're called Chinook winds. Foehn winds are associated with the downwind side or leeward side of the Alps. The word Chinook, if you read it in your textbook, I think, it says Chinook is an Indian word for snow eater. So these, anything that goes down, and actually it's going to be the same thing with Santa Ana winds, any wind that goes down like this, if you can take a chunk of air for whatever reason and make it go down, it's going to contract and it's going to get warmer. It's the opposite of adiabatic cooling, it's adiabatic warming. So that's what happens. You can see that the chunk of air can go from, change its temperature 40 degrees. It gets 40 degrees warmer and going to be very fast moving winds. So Santa Ana winds are kind of like this too. We'll take a quick look at this video.